In this lecture video we are discussing about the Gattermann Koch reaction. And what is Gattermann Koch reaction? When benzene is react with carbon monoxide in presence of hydrochloric acid and Lewis acid AlCl3 or CuCl give benzaldehyde, and this reaction is called Gattermann Koch reaction. Here what is Gattermann? When benzene, this is benzene ring, when react with CO carbon monoxide gas in presence of HCl hydrochloric acid and AlCl3 catalyst or CuCl catalyst give benzaldehyde. When benzene ring contains COH functional group, this is benzaldehyde, and this reaction is called Gattermann Koch reaction. And what is the mechanism and how this product is obtained? Now see here mechanism, the CO, this is CO molecule, and in CO molecule in between carbon oxygen there is double bond. Here carbon contain one lone pair electron, oxygen contain two lone pair electron, and for the electrophilic substitution reaction, what happen, the lone pair electron from oxygen shift towards carbon to give carbon oxygen multiple bond. And when this lone pair shift towards carbon to form here multiple bond, oxygen lose electron, it develop positive charge, carbon gain electron from oxygen, therefore it develop negative charge. And here oxygen contain one lone pair electron, negative charge, this carbon contain one lone pair electron. And this chemical species, this CO in oxygen positive, here oxygen contain one lone pair electron, and that react with HCl hydrochloric acid. And first this negative charge carbon, attract H plus from this HCl to give Cl minus, and when H plus combine with C minus give CH bond, or it undergo resonance to give, when this pi bond shift towards oxygen, because here oxygen more electronegative, already it contain one lone pair electron, and when this pi bond shift towards oxygen, the positive charge of oxygen neutralize and it acquire two bond, two lone pair, and positive charge shift into this carbon, and carbon having positive charge that act as a electrophile. And in next step what happen, what is the function of this AlCl3? Actually this positive charge carbon combine with Cl minus to give carbon chlorine bond, but due to presence of this Lewis acid, these are electron deficient, and it always try to attract electron rich center, electron rich species, therefore this AlCl3 attract this Cl, and this AlCl3 attract this Cl with along with lone pair electron. Then what happen, here Cl minus by migrate to AlCl3, and when AlCl3 and Cl minus combine give AlCl4 minus, and again here in carbon there is formation of positive charge carbocation, or and it act as a electrophile. And in aromatic ring there is electrophilic substitution reaction, and when we are carrying out electrophilic substitution at this carbon, then what happen, this pi bond shift towards this carbon. When this pi bond shift towards this carbon, what happen, this carbon gain positive charge and this carbon gain negative charge, and negative charge carbon here form bond with positive charge carbon, this COH positive charge carbon. Then here in between these carbon and this positive charge carbon there is formation of bond, and give here at ortho position there is positive charge. And next step what happen, it undergo cyclic resonance, and finally to give product what happen, here carbon hydrogen bond, this carbon hydrogen bond shift towards aromatic ring, and when this carbon hydrogen bond shift towards this aromatic ring, here formation of multiple bond, aromatic character is obtained, CHO group here functional group remains COH aldehyde functional group, and this removed as H plus hydrogen, and this HCl is also a catalyst. There is simply a reaction between benzene and CHO, because in one of the step there is involvement of HCl, and in final step there is release of HCl. Therefore HCl, AlCl3 or CuCl, these are catalysts, and simply here aromatic ring and CO react to give benzaldehyde. This is Gattermann Koch reaction, and finally what happened, this H plus and AlCl4, from AlCl4 Cl minus combine with H plus to give HCl again, and there is release of AlCl3, and this is the Gattermann Koch reaction and the mechanism behind this Gattermann Koch reaction.